Hi guys, welcome to Involved Innovation YouTube channel. In this video series, we will see about Docker. If you are a developer or a DevOps engineer, it is very important to learn and understand the Docker. Docker is an open source platform for developing, shipping and running applications. Docker enables you to separate your applications from your infrastructure so that you can deliver software quickly. Before going deep into this definition, we will see why Docker is needed and what problem Docker solves. First, we will see what problems we have in application development environment and how Docker solves it. For example, if you are using macOS for your web application development and you are using Node.js version 13 for React and Server and RabbitMQ for asynchronous messaging queue and Postgres version 12 as the database backend. Your infrastructure team says you need to upgrade to Postgres 13 in your next release. So, you upgraded to Postgres 13 in your local system. Now, there is a production defect. You need to replicate the production environment. In the production environment, we are using Postgres 12. Here, we need to change from 13 to 12, and once the bug is fixed, you need to switch back from 12 to 13. So, changing version is a headache. Now, there is another person who is joining the team and he is given with a Windows system. Now, you need to set up a similar environment. What you have in your local. You are using macOS. In this case, since his operating system is different from you, you can't share the installation setup guide which you might have created. So, he needs to spend more time setting up similar environment setup. Let's take, he brings up the similar environment setup after some struggle in Windows. Now, pushes the new functionality to the testing environment. To everyone's surprise, the functionality is not working as expected in the testing environment, which was perfectly working in his local environment. This is another issue which can be solved with Docker. There are many possible reasons why the code which is working in his local system is not working as expected in test environment. Configuration might be different. Some code files might be missing. There might be version mismatch in some of the software or library. As a whole, we found there is three main problems to tackle. First, maintain different version of same software. For example, here we need to maintain Postgres 12 and Postgres 13 simultaneously in the same environment. That is really challenging in your local environment. Make setting up development environment easy. Here, this is hassle if a new developer joins in. If there is something which makes the setting up development environment easy in few clicks, that is great. The functionality which is working fine in your local environment might not be working fine in stage or production environment. This is a bigger issue. Here where the Docker comes to rescue. Docker solves all these three problems with the use of containers. We will see what is container later in this video. Here I will just give a gist about containers. Docker containers are isolated environment which is running on top of Docker engine. Containers have their own process and their own network interface. We will see more about the container later in this video. Container shares the OS kernel on which this Docker engine is running. For example, if the Docker is installed on a Linux OS, it will utilize the Linux OS kernel. And there are major advancements here which I will talk about later in this video. We can install different containers with different version of same software like Postgres 12 and Postgres 13. As I mentioned, each Docker container is an isolated environment. So each can run independent of another. Next issue, setting up development environment process easy. We can set up development environment with a single command using the Docker Compose. The Docker Compose app will create all the necessary containers with the required softwares in it. We will see more about Docker Compose later in this series. Next and the most important one, to resolve it works on my system issue. We can build a Docker image from the Docker file and run it on the container in your local system. Once we feel the functionality is working fine, then we can push it to the cloud image repository. Here the image will run in any container the same way as it is running in your local system. We have seen why we need Docker. Now we will see what is major difference between virtual machine and Docker, because these three issues which we discussed can also be solved using virtual machines. Virtual machine versus Docker. First we will see about virtual machine. Virtual machine is a complete operating system which resides on top of the host operating system. We have a guest operating system which resides on top of the hardware. For example, the guest operating system can be Mac or Linux or Windows, any operating system. Now we need hypervisor. The hypervisor is an application which resides on top of operating system. The famous hypervisor for this type is VirtualBox. The hypervisor can be of two types. One is which resides on top of operating system, and another type is which residing directly on top of hardware, which is also called as bare metal hypervisor. Here on bare metal hypervisor, virtual machines can be installed on top of this hypervisor. The famous bare metal hypervisor is VMware, Sphere and Windows Hyper-V. In this example, we have 4 operating system which is running on the top of guest operating system with the help of VirtualBox hypervisor. We will see about Docker. Here the Docker engine resides on top of host operating system and uses operating system kernel. The operating system kernel is a connecting link between the hardware and the application installed on the operating system. Here the Docker engine uses OS kernel, the Docker containers running on top of Docker engine. Containers are runnable instances of an image and they are in isolated environment. Each can run independent of another. Since the containers are running on Docker engine which runs on OS kernel, only the Windows compatible image file can be run on Docker engine which is installed on top of Windows operating system. As I mentioned before, there is a major advancement in that which we will see shortly. Whenever you are creating a virtual machine, you need to provide the RAM size you are dedicating to this operating system to run. Let's take you have a system with 8 GB RAM. You are restricted by the hardware memory and the RAM memory you have in your hardware. So you can create 3 virtual machines which running parallelly with 2 GB RAM each, providing at least 2 GB for the host operating system. Booting up a virtual machine also takes time because you are booting up a whole operating system, and deleting and creating a virtual machine is not easy as creating containers. Containers are compact, portable units in which you can start up an application quickly and easily. Unlike virtual machines where virtualization happens at the hardware level, containers virtualize at the app layer. We will see what is Docker image and Docker container and how it is created. Docker image is an immutable and read-only file that contains source code, libraries, dependencies, tools and other files needed for an application to run. This image is also called a snapshot because they represent an application and its virtual environment at a specific point in time. Docker container is runnable instance of an image. Once you create a container, it creates a read-write copy of an image in this container and the existing image remains read-only. For example, here in this case, the original image has 4 layers. Once you are running this image in a container, it creates a read-write copy on top of these 4 layers. You can now create an unlimited number of Docker images from one base image. Each time when you change the initial state of an image and save the existing state, you can create a new template with the additional layer on top of it. At the core, Docker container is a virtualized runtime environment where the users can isolate applications from the underlying operating system. We will see how to create a Docker image and how to run it in a container. We need to create a Docker file to create an image. The Docker file starts with the base image. This is why we call Docker image as layered. Each image which we are creating is built on top of another image which is called as base image. For example, in the case of Redis image for Linux is built on Alpine. Alpine is a lightweight Linux distribution based on Muscle library and BusyBox. In this case, we are going to build a React web application. If you are not aware of React, just understand how we are creating a Docker image from a Docker file. First, we need to start with base image. For React, node is the base image. For example, if you are creating a Redis image, then you need to provide the Redis image as the base image. Next, set the working directory. Then set the environment variables if any. Copy the package.json file from local to Docker image. Then run executes the command in the new layer and creates a new image. Here we need to install all the necessary dependencies which is present in package.json. So we are executing this command in run. Copy the code from local machine to Docker image. Finally, cmd statement will be executed when the Docker container is started. We will see how to create a Docker file and various commands in Docker file in forthcoming tutorials in detail. To create Docker image from Docker file, enter the command docker build -t image name is optional. This command builds the Docker image from Docker file. Then, to run the Docker image in container, execute the command docker run -d followed by image id. Now, this image is running in this container. That's why we call container as runnable instance of an image. Here, image is a template and container is a process which is running that particular image. We already saw all the images are OS kernel based. Now we will see what images are accepted in 3 major operating systems. In Windows 10, you can use both Linux and Windows image. This is made possible because of the Hyper-V in Windows 10. As I mentioned before, Hyper-V is a bare metal hypervisor. Bare metal hypervisor which sits directly on top of hardware. We can install operating system on top of this hypervisor. We have host OS which is Windows 10 and we can install Linux VM of our choice. The Docker engine can make use of underlying Linux VM kernel to run the Linux based image and Windows kernel to run the Windows based image. In Linux OS, we can run the Linux based image by utilizing the underlying Linux kernel. In Mac, things are a little tricky. Whenever you are installing the Docker in Mac, you are also installing the Linux kit, which is a lightweight distribution of Linux. The Docker sits on top of this and we run the Linux based image which uses the Linux kernel in the Linux kit. Thanks for watching this video.